This is our second question that is asking us which of the following is true for actual integrated circuit op-amps. We have a previous question, and this is in the playlist with the other problems, and it's asking us the same thing except we have different options. But they're very similar, and we are going to look back at both just for reference. So we're going to start from the bottom and go to the top. So for E, it says they're almost always used to build amplifiers employing positive feedback. Now, this is the same thing as B in the previous question, which we know is not true. And that's because of this positive part. They are almost always used to build amplifiers employing negative feedback. So if this were negative, it would be true, but since it's not, it is false. Next, we are going to skip the none of these ones. Now we're going to look at C. They depend on accurate resistor values to set accurate closed loop gain values. This is very similar to D, which was correct in the last one, where it says they depend on the ratio of resistors to set accurate closed loop gain values. The reason why it was true for this one and not for the current one is because when we calculate gain, it's a ratio of our resistors. Now, the accuracy of our resistors is not what determines the actual gain values. It is the ratio. The accuracy can be whatever we like. It will affect our gain, but it is not dependent for our actual gain itself. So the fact that it depends on the accurate resistor values means that it is false. Next, we look at their open loop gain decreases as frequency increases. And previously, we have that the open loop gain decreases as our frequency decreases. And this is the same thing. And we said last time that our frequency, it's the negative feedback makes the closed loop gain feedback insensitive to changes in the open loop gain. And this is the same thing in reverse. So we are not decreasing or increasing since it is insensitive, and so this is false. And now when we look at A, we see that they trade away extra open loop gain to achieve more accurate closed loop gain values. And previously we've had another similar question where it says they trade away closed loop gain to achieve more accurate open loop gain values. Now for this one, they trade open loop gain, which is what we're doing because we're going through here. We trade this open loop gain, and then we go back here with a closed loop to get more accurate values. It even says right here, negative feedback trades high open loop amplifier, and the open loop part is the important part for everything else that we need. And what we need is more accurate amplifier gain for our closed loop. So it really says this in the notes, which are in the description. So this would be true because they, the actual integrated circuit op-amps, they do trade away extra open loop gain to achieve more accurate closed loop gain values.